All right, guys and ladies, this is a little bit of a finish up of the lab activity we were doing on April 16th, last day of class, before the test. So here is the Google Colab workbook I was using, and it's up at the top of your project notebook, which I'll kick that out again in this announcement. So here's your project template in a sense, although that doesn't mean you should just copy this and give it back to me for the project. By now you should have finished the project, but this is just to give you some idea now that your mind is warm for this stuff to understand what it means to build your own question answering AI language model trained on a teacher model such as we're going to be using Roberta in this case. So anyway, the text is here, and also the link to my Google Colab notebook is here. So a couple of things you got to do to start with. Number one, I mean, if you really want to do a big model, like if you want to, train it on 50,000 characters, for example, of training data, you're going to have to spend a little bit of money. Not much, $1 or $2, but you would need to go and buy some compute. But at least, even if you're going the free version, you see I'm here on the T4 GPU graphic processor unit. Right, Google Colab is pretty nice. They're giving you some pretty good stuff for free. So also hardware accelerator. I don't think you're going to get that for free. Well, we could give it a try, I guess. They're going to give me that for free? You're joking. Wow, that's pretty good. That's a GPU hardware. Oh, well, cool. I was using this one before, so you could also play with that. Anyway, save. Now, my code, my working code, my final, all of this stuff was stuff we developed in class to motivate the concept, to understand the connections. However, now that we've got our final working version, it is down at the bottom. That's all the stuff we did in class. Now look, this is this is one way at least of doing making your own generative AI language model trained on a teacher model such as Roberta, or you could use Vicuna or ChatGPT 3.5. I went with Roberta because it allows longer contexts, and yeah, you can put more into it, and it'll give you more back out as an answer. The downside is it takes a little bit longer, but anyway. Now here's my training data. That's what I'm going to train on. Now, a more completely correct way to do this would be to put your training data in a text file. If you it has to be on Google Drive if you're working on Google Colab Notebook, because you cannot connect to your local file system on your computer. So you could make a directory, and we've seen how you could mount the directory and you could access the file from your Python code in Google Colab. However, to keep it simple, that's not a project requirement, so I'm just going to hard code it in here for now. So here's just some stuff I copied and pasted from Wikipedia, early computer. Now this is a line I added by myself. Now I'm going to do a test, right? This is something I haven't done yet. We'll see it together. So I asked it the question initially, why were early computers, why did they use a lot of electricity? Remember, I demonstrated that in class and it just blanked out. It didn't give me an answer. Why? Because that was not in the training set. Now, I added this in manually. Just a couple of minutes ago, I typed that there. They used a lot of computer electricity, very slow, generated heat. Vacuum tubes are a very inefficient way of realizing logic gates. And I asked it the question, why were early computers very slow? And it gave me that exact line back out. Now, as a test on its reasoning, I also just added this in here. I have not run this yet. We're going to see this together right now. Another reason early computers were very slow because the Earth rotated faster in those days. First of all, that's not true. The Earth has not changed its rotational speed. Second of all, even if it did, how would that affect the running speed of computers? So I'm curious to see how my AI model here deals with these two seemingly like they're statements which are kind of irrelevant and a little bit contradictory. So let's see how it works. So now I've set up some compute, right? I've gotten some, and I've never tried, well, I do have a paid account, but I didn't use my credits for this. So, because I want to do the same thing you guys are going to be doing, and I want to see with whether the free version you can use the hardware accelerator. So we went here, right? We did all of that. Now we're going to click to run, and this may take a couple of seconds. I don't know how long this is going to take. So run your program, which is in this cell. And if it takes too long, I'll just zip this out of the video. It may take a while. Ah, that was actually pretty fast. Now look here, it went and generated all of our config files that we need. So there's your tensor, your JSON config, your vocab, and so on. We can go here and see if we can find it in Google Notebook. Google Drive. Yeah, there it is. So there's the Google Drive directory for your project. And actually, no, this is from another project. This is not this project. And I'm not going to detour into this. If anybody wants to see file handling in Google Drive, I'll do that later. But that was for another project. That was for some real estate thing I was doing. Anyway, we should be good to go now. So now let's ask, why were early computers very slow? Remember, we're using the Roberta teacher model to train our student model here. And you can go and study through the code. So there's where we're setting up our transformers. There is my model. So a Roberta model fine-tuned on a training methodology called Squad. And this is other stuff we talked about in class. So student, as we said, does not mean student as in you're a student. It means your AI model, which has been trained from a teacher AI model, which is Roberta. So why were early computers? By the way, a couple of interesting things. Number one, I am using Hardware Accelerator. They gave it to me for free. Number two, this ran very quickly. When I did it before on the simple T4, it took about 3 minutes to get started. So on the Hardware Accelerator, it started in, I don't know, like 3 seconds or something. Now, I'm guessing that after I do this a couple of times, they might pop up a message saying, thank you for enjoying Hardware Accelerator. If you want to keep it going, you have to give us some money. But anyway, we'll deal with that later. So why were early computers very slow? One reason is because vacuum tubes are a very inefficient way of implementing logic gates that is rational and reasonable and truthful. The Earth rotated slower in those days. First of all, is not true. Second of all, has no connection with how fast a computer runs. That's my little test on the reasoning capabilities of the Roberta model. Why were early computers very slow? Press the Enter key. Actually, that's very fast. Before in the class, remember, it took about 2 minutes. Now in the Hardware Accelerator, it's happening virtually instantaneously. The Earth rotated faster, which was nonsense. So the second thing I put in there, it didn't even mention the issue of electricity. All right, so since this is pretty responsive, let's terminate this by clicking up there. Let's going and changing our training data. By the way, remember I told you one of the emerging job categories that's going to be out there for you is cognitive systems trainer. Well, this is what a cognitive systems trainer do. They provide optimal, or at least the best available training data, and then they also do something called hyperparameter optimization. So I'm going to get rid of this nonsense statement, which I'm very disappointed that it said that. I was hoping Roberta was a little bit smarter than that, but anyway. Let's get rid of that, and we don't have to save it because it's on the web, and let's start it again. So start. Why were early computers very slow? Why were early computers very slow? Now it's spinning away. Vacuum tube. Yeah, so now it's giving me the correct answer based on my training. Now, if I were to ask a question like this, where was the first computer invented? Enter. And this is very fast, by the way, so definitely use that T4 hardware accelerator option. Bell Labs. Actually, that's true. And that was not in my training. And that's coming from the Roberta teacher model because Roberta knew that. Now, actually, I was kind of expecting, to tell you the truth, what I was expecting to get from that was that it would say it didn't know. And if I use ChatGPT 3.5, ChatGPT 4 is not available to little people like us, by the way, just letting you know. But ChatGPT 2 and 3 and 3.5 are. That has a good general knowledge of the world. I would have expected it to answer that. I'm actually pleasantly surprised that Roberta knows this. Let's ask a larger question now. Why did computer adoption in the 1960s and 70s change the constitution of the job of the sort of what I'm just trying to say, like change how people's jobs work. Change the, I guess I should make that text box bigger. Change the layout and just what's the right word here? Change the nature of employment, I guess. Change the nature of the employment of employment of jobs of let's keep it simple and say employment. And I will be very impressed if Roberta knows this because that's not at all in my training set. Holy jeez. Well, it's actually that's all stuff from my training set here. Uh yeah, it's giving me everything from my training set, but it is not in this case answering the question about jobs. Later on, maybe tomorrow or something, I will do this again. I'll kick out another video. I'll train it on ChatGPT 3.5, and we will comparatively do the same exercise. You remember that I did ask you as a stretch. You didn't have to, but I said it would be great for your project if you trained it on a couple of different models and then did your own KPIs. All right, let's ask one more question here. Uh, why did early computers not use microchips? I mean, we know the reason is that it wasn't invented, but let's see how Roberta handles this one. Do you guys like this? Is it fun? Yeah, it's a good paying job. If you get excited about this, then being a cognitive systems trainer, that is going to be an emerging job category. So jump into it and get it because the early movers in any new technology always do the best. Why did early computers not use semiconductor memory? Semiconductor. The correct answer is because it didn't exist. But let's find out how Roberta handles this. And it may take a while. Oh, actually, you see the S? That's just a placeholder that says, I have no idea. Stop pestering me with your stupid questions. But I kind of get the feeling when I rerun this on ChatGPT, it'll go out to its teacher and it'll get access to that. What else can I say here? That's about it. That's what I wanted to show you. Maybe I could say, what is a first generation computer? Because that's in its. Now, you see, the way my model is working here is if it doesn't know, it dumps out its whole training set. So anyway, it's thinking, vacuum tube. Oh, right, actually, the answer is already here. Sorry, vacuum. Yeah, that's correct. That's a good answer. Maybe I'll ask something about ENIAC. Tell me about ENIAC. And it's interesting, it's dumping out the whole training set. I would have thought it would have answered that because it knows what ENIAC is. Anyway, oh, Bell Labs, because I asked where computers were invented. I was impressed that Roberta knew that. I forgot that was in my training set. So Roberta is not bringing you any world knowledge. There's other models that we'll get to later. Anyway, guys, this is some stuff if you want to look at this and play with it. This is what a AI language model in the very simple sense looks like. You see the limitations now, so you understand the sort of implications of using different teacher models. And I hope if you want to get into this for a job, just make it part of your daily practice to spend, 15 to 30 minutes a day playing with this. And if you need help, let me know. All right, we're going to wrap up the video for right now and be in touch with me if you need more information.